So my discussion is going to be about using an Arduino and configuring it for DCC. When DCC first came out, all right, typical DCC, you had to have a cab and a command station and a booster, power supply booster. The problem is that cab and the command station are all proprietary. If your neighbor didn't have the same kind, you couldn't use your cab on his layout. So the reason that the NMRA specification is very important is it allows people like me and a bunch of other people to tinker with the idea. If we know what the signals need to be, then we can design a system that's open source that anybody can use, okay? Which is exactly what a bunch of guys did. So they took you go back a step. The major DCC wired protocols that are out there are, for Digitrax, you have LocoNet. It's proprietary. Lens has the ExpressNet, NCE, cab bus, Easy DCC cab control, and MRC has Prodigy. But there's many, many, many more. How many manufacturers of DCC equipment do you have? The thing is, the only thing that's proprietary is that cab to the command station. From the command station out to the booster or to the track directly is the NMRA specification. So we can come up with a nice system. There's no reason for it to be proprietary. All right. So they came out with this thing called DCC++, and it was just an idea in the beginning. And they said, okay, because JRMI, which is Java Model Railroad Interface, is all open source, right? They said, let's start with that. So they started with that, and they developed in JMRI a methodology to pass signals in a standard bus format, and just use a USB, right? That would go to a command station. But they also had to write the command station. So they set about doing that, and they said, well, what are you going to put it on? What would people like, right? Well, after they wrote it, they said, this thing really isn't very big at all, right? It's the manufacturers have been telling you that, oh, it's so complicated. You need our lens system. No, NRC, you need that system. No, you don't, okay? So typical DCC++, the plus name means that it's not proprietary. Anybody can use it, right? So they started out with an Arduino Uno, and I've given 4 already talks on Arduino Unos. They're small little guys, not much big, not much, a little bit smaller than this, all right? And it's all open source. So they started with that, and they said, well, the signal that's being produced is your typical DCC signal. Is a bunch of pulses, right? But we're dealing with direct current here. Okay, so we can use an H-bridge. Engineers know what that is. It's power, and you have the H-bar across. So if you turn these two on, the power goes this way. If you turn these two on, the power goes this way. So you can get rise and fall pulses using that. So sure enough, they have, if you remember in my previous talks, these new add-on boards that you can stick on top of an Arduino. They just stack on like this, okay, are called shields. So, and there's a lot of motor shields out there, right? This one that's on here happens to be 2 amp, all right? So 18 volts, 2 amp, which is all it'll handle. It doesn't have a heat sink, all right? You can get ones that are much more robust, all right? You can get the 18 or 19 volt, it's 12 volt, 2 amps. You can get the 18 volt, 24 volt, 10 amps. They all have them all the way up to 40 amps. It's just called a booster, right? That's all it is a booster, right? What's nice about, however, boosters is, commercial boosters, they usually have the circuit breakers internal to them. Believe it or not, the circuit breaker that's in the circuit here is faster, right, than any commercial circuit breaker. Right? This thing operates in about 30 microseconds, 30 millionths of a second to detect a short circuit, and it just opens up all four sides of this H bridge, and the power turns off. It's pretty fast, okay? All right, so in so what they had to do, what was the major work they had to do was the sketch, which is called the program, right? The DCC sketch does every single thing that the NMRA says it should do, and then some, all right? It has properties to handle auxiliary closures on computers like an Arduino or a Raspberry Pi or any of the other little ones. It can open and close inputs and outputs. It can acquire and spit out analog voltages also. It's all included in there. Let's see Lents do that. Okay, they don't do that. Right? So, and it's all open source. And you can look at it if you want to and play with it. And if anybody knows your basic C++, it's written in a derivative of C++. Okay? So, now what we have a system. So they said, well, that's really pretty good, but problem with JMRI, it has to be resident on a laptop or something like that. All right? Well, you're not going to walk around with a laptop and try to control or have to run from station to station. So what they said is, let's take it one step further. All right? By the way, when you do put this in an Arduino Uno, right, there's about 50 bytes left over. Right? So you can't control any I/O or anything else with it, right? But it works, and it works great. Okay. So then they went to something called DCC++ EX, which is an extension of that. All right. So it's still JMRI. You can use that. But you have to use something a little bit bigger. In this case, it's an Arduino Mega 2560.
It's bigger than that 50 byte.
Yes.
Okay.
Right. Here you've got about 3.5K left over, which is pretty good. All right. Same dual channel H bridge motor shield. By the way, it's 2 H bridges on there, and one is for programming, one is for the main line. Okay. And the differences that we know is
no track power.
There's no track power when you're on a program, when you're doing programming. That way, the thing won't take off on you too. Same now. However, now there's some more extensions to it. It is extended. We can put a Wi-Fi shield on top of the motor shield, and now we can control it with Wi-Fi. You can either use a one-on-one, where you can set the Wi-Fi shield up to be a single channel, right? Now, if you use a single channel, but you have a multi-throttle, okay? The one I have on here is engine driver. This engine driver has 4 channels in it. So I can run 4 engines on that one communications channel, right? That goes back to the Wi-Fi card. Or you set the thing up in the station mode, the Wi-Fi card, and it's just like the router in your house. Right? And it'll handle about 40 channels, 40 different devices, each of which can have 4 engines on it. That's a lot. On that little thing right there. Just that right there. Of course, you're going to have a bigger power supply out here. Okay. So that's how I have this set up. There's the router right there, right? And you can use an Android cab, which is what I have, or an iOS cab, which is Y-throttle. Okay. Now, so what they did was, which was really good, Y-throttle is a protocol. Okay. the iOS happens to be called Y-throttle, right? But it's not this Y-throttle, right? Because it's open source, the name is not copyright, right? So they decided to use it. I don't know, right? But the Y-throttle is a protocol. JMRI actually talks to the Arduino Mega using the Y-throttle protocol over USB. So this is the Android cab uses Y-throttle protocol to talk to the Arduino, right? But over Wi-Fi. Okay. Well, now it's very nice. Look at it. NMRA, very well established and well written. Open source, open source, open source, open source. You can do whatever you want, right? You get the manuals for this, right? You get the manuals for that. You get the manuals for that. And you can change whatever you want. That also means that all of this doesn't even need to control a model railroad. You can control other stuff with it. Okay? Your house. So that's what I did. You can also use throttles for PC for if you like computers, the hardware. DCC EX, they have an EX web throttle that you can load on here, and it will talk directly through the USB port. Or you can go through JMRI and set up a throttle in that, and you can talk to your engine that way. Now, here's all the smart throttles that are currently available as apps. You can get them right out of the App Store, your particular App Store. Engine Driver for Android, which is the one I have. However, you got DCCPP CAD, right? You got CAD Engineer. You can see all the different ones there. The one that you want to get, by the way, is Y-throttle, which is the best one for the iOS. And there's many more, right? This might be a little bit fuzzy. We don't have to go through it all. But here's the EX features, right? Fully compliant with the standards, 2 and 4 byte locomotive addressing, so that's shorts and longs, okay? Simultaneous control of multiple locomotives. Yes, you can have 40, no problem, all right? 128 steps. So none of this, it's small, it must be, only 24 steps. No, it's full 128 steps. Control of all cab functions according to NMRA. So you have these functions F0 through F28. How many is that? There's 29 of them, right? Activate, deactivate all accessory function address. So you have accessory addresses all the way up to 2048, right? And that struck me as kind of weird because that's 2049 addresses. Mm-hmm. But it is. It works. Program on the programming track, so you can write all the variables and read them and do all kinds of stuff, and you can get a report out of it, okay, that you can print. Full reports on your all your variables, all your CVs that are in your engine already, plus all the hidden ones that you never see, okay? I was working on one decoder where both diesel and steam are in the decoder. And you had to dive down using indirect addressing, or they call it indexing, I think, using the indexing addressing mode, and you flip one bit, and it turns the decoder into a steam decoder. But all the sounds are in there also. All the steam sounds are in, just flipping one bit, right? I had to search. Well, what I did was I went and I got the reference manual for the decoder, right? It was 178 pages long, right? And read it all and poked and moved and did this and did that. And you can see all the different sounds and functions. You can combine them. You can do this. It's unbelievable. And yet people don't make use of it. They go, I don't want to look at that. What's good about an open source system? You can look at everything. You go, oh, click. Right? 4 different diesel horns, right? 4 different steam whistles. Yeah. What else? It also has direct access and control to all the Arduino I/O pins for accessory functions and sensors. Okay. So, this is not going to be a lecture on the software. It's way too complicated. It's hardware, all right? So, let's do what we can do here. DCC++, like I said, Arduino Uno R3 can do it, but it uses almost all the memory, right? And also doesn't have Wi-Fi. Okay, that's the EX. But for the DCC++ EX, you're going to use a Mega 2560. It's about $20. You want to buy 5 of them, right? They're about $16 a piece. You want to buy 10 of them, it's even cheaper. Right? So it has plenty of memory, plus it's got a gazillion I/O pins in it, right? And the important thing is it's got 32 registers for the Wi-Fi. Well, what's good about that? Well, remember I said, right? You can run 40 engines. Well, you kind of can, right? There's only 32 registers available to the Wi-Fi. You see what I mean? So, but that's still a lot, right? Have more than one, right? All right. So this is the Mega. So what do we need? What else do we need? Well, we need that H-bridge, right? This is a Deke robot, L298, and the L298 is the name of the chip. So you're going to find a lot of, if you type in H-bridge Shields Arduino, you're going to get a list of 8 or 10. They all have some name of L298 in them. By the way, the P happens to stand for pins. That's all. So you have an M for, you have an S for surface mount. You've got different, but they're all 298s. This is a 2-channel, 2 amps per channel. Okay, H-bridge, $6. Okay. The Wi-Fi. This is a Maker Fabs 8266. You'll see that too. 8266 is the name of the chip. Okay, lots of people make them, and they make them for Arduinos. This one's $9. Could have gotten it for $1.50, but I would have had to have programmed it myself. Oops. All right, so the heck with that. Right?
$750.
Yeah. Yep. So this is this is a good one. Works very well. There it is right here. It's got an omni antenna on it, omnidirectional antenna. So this one is broadcasting in a ball, whereas this guy here is sending and receiving in a horizontal plane. Okay. Okay. So, gee, we're not into it in hardware very much, are we? You know? That's a full. Now you got to. Well, there's a couple other things you got to buy. Well, I need some. I need a power supply. 9 volts for the Arduino. Why 9 instead of 5? I thought the Arduino was 5. Problem is, right? When you put 5-volt external 5-volt power supply into an Arduino, right? That has a 5-volt regulator on it. Okay, as the regulator is going to run wide open. It's not going to regulate at all. It's just going to say, okay, I'm a short circuit. It turns that pass transistor on 100%. Okay, which means that as you load and unload the system, that 5 volts is going to dip up and down, up and down. You put the 9 volts in there, right? You got plenty of moxie behind it, and then you're only driving the voltage regulator at about 40%. So it's got a lot of room to open and close and let more power in as the load increases or decreases. motor shield. So I got a 12 volt, 5 amp, 60 watt power supply. The card goes up to 18 volts, right? But it's limited to 2 amps. I bought that one, okay? And that's $13. We're still not up to very much money here, right, for a full-blown DCC system. Okay. However, see, motor shield operates at 12 to 30 volts. I said, it's 30 volts it goes up to. The Arduino voltage, better, but watch out, is 7 to 12 volts, okay? The max for the Wi-Fi shield is 5 volts. We got a problem here, okay? So we must isolate the motor shield voltage from the feed-through pin that's in this stack here, right? So there's a couple of ways to do that. When the board that's on top doesn't use the high voltage pin, so that's not a problem. It only uses a 5 volt pin. The middle one, which is motor shield, I've got 12 volts going into that, but you don't want that to fight the Arduino voltage. So what we have to do is we have to isolate the motor shield voltage feeding through the V-in pin. And the way you do that is, and they're all made this way, is you turn the thing over and sure enough there's a trace coming from that pin, okay? Because here's the edge connector. Here's the edge connector. There's the V-in pin, right? Very nicely, they put this trace on here that you can cut, okay? So sure enough, that's what you do. You sit there and you cut that trace, and now it's only in my case, the 12 volt power supply that's feeding it, not the 9 or the 5, and they don't conflict with each other. Or you can just bend the pin out of the way. And here's the motor shield, and sure enough, there's the pin. This is the Arduino down here. You just bend the pin out of the way. And you'll isolate it that way if you don't want to cut it. So I chose to cut it.
Drop of solder fixes it.
Yeah, a drop of solder fixes it. So you're going to put it all together. But here's something else. The Arduino needs to communicate with the Wi-Fi throttle, okay, or the USB, right, fast enough to interrupt power for a short circuit, okay? So you have to operate it at 115.2 minimum. You can go higher if your equipment will handle higher, okay? Why? Well, this is 115, the USB signal is 8 data bits, right? And I think there's and one stop bit, there's another one, there's 10 bits, right?
Typically 8 and 1.
Yeah, it's usually 8 and 1. Okay, but there's usually another one that's in there someplace. At any rate, 10. I'm figuring 10. So that's 10 to get an 8-bit word, right, through the system. Well, if you divide all that out, and this is basically bits per second, right? You divide it all out and you say, oh, geez, that's microseconds. So that's why you have to have a high rate. I've seen people come and they say, it doesn't work, it doesn't work, it doesn't work. 9,600. Okay. Now the other caution that we have is the Arduino versus the Wi-Fi. The Mega versus the Wi-Fi. Arduino is full duplex. Okay? That means simultaneous asynchronous transmit and receive per channel. Okay? But the Wi-Fi shield is only half duplex, which means transmit or receive on a single channel. But it's got 8 channels. Okay? So what we're going to do in order to get fast communications, is we're going to use the transmit from one channel and we're going to use the receive from another channel so that the program sees simultaneous transmit and receive. Okay, that's how you take care of that. So let's assemble it. Well, that's not hard to do. You take the Arduino and its 9-volt power supply. You put the motor shield with its 12-volt supply on top of it. You line up the pins. You can figure that out, right? And then you press the Wi-Fi shield on top. Now, but we need to communicate. There's no communication path through the motor shield, so we've got to put a couple of jumpers in from into the Arduino communications path. It's transmit and receive up to 2 different channels, one transmit, one receive on the Wi-Fi board. So there's some pictures of this right here. Okay, y'all can come up and see it and whatever later. So software. Software is the big thing. This is all open source. It's DCCEX.com. They have a downloader. You can do it by hand. You can do it manually, or you can use the downloader. The downloader just makes it easy. It asks you a couple questions. You answer the questions. It loads all the right drivers. All right? So you go to DCCEX.com and you can read all about it. I'm not going to tell you all about how to install it. You've all installed software before, right? Just install it. But that's where we'll go. So now we're going to give it a try. What we have sitting out here this is an Atlas Trainmaster Gold Series. This is a Lackawanna number 850. This engine was purchased in 2003. It's got a QSI DCC plus sound decoder in it. This engine has about 6 hours on it, that's all, from 2003. The guy that bought it didn't live long enough to put a lot of hours on it. Okay, so that's unfortunate. So I picked it up as an estate sale, or I went in and bought all his stuff. So here it is. Do we have any questions right now? Nope. Okay. Let me go back one second. So let's fire this up. What I have done is the Arduino is not running on this machine. I don't have it running, so I'm not cheating. I got no connection here. Okay. I'm not talking to it at all. So the program is all preloaded in here. I loaded it all in. And let's see if we can get this guy running. I sure hope this works. So first we got to do is turn on the power. Come on. Sure sounds like that's power on. Okay. So I'm looking at my thing. I should have had this printed out, but I didn't. I couldn't take a picture of it with my own. And then every time I pushed up here to try to take a screenshot, it would change this. So it's something about the driver, the engine driver. So let's start. That's the engineer opening the door to go into the cab.
There he is.
He's getting his board set up, starting everything up. So there he is, right? So let's see. Let's turn on some lights, and they'll go on when it moves. This particular decoder has 2 different modes, idle and quote-unquote moving, even though it's not moving, even though speed is at 0, okay? But idle and certain things come on. Let's try a bell. How about a horn? Now, what's good about that is I had mine set up as non-latching. The bell, you noticed, was latching. You press the bell, it stays on. My horn is unlatched, right? So I can press it and hold it. Or just give it a couple toots, all right? There's lots of other things in here. There's motor fans. There's Doppler effect. So as it passes you, you can hit the Doppler, and as it goes past you, you hear the sounds go down. All right. It's got. I turn the number boards on. Short air. You hear it? Let's see if it'll move. I sure hope it does. There's a ton of sounds with this thing. Okay. Reverse. That's not bad for 2003.
Mm-hmm.
Okay? But that's because I used Andy's handy-dandy #1 cleaner on it. Remember I told you all about that stuff? That's all I've ever done. Right? And remember, that stuff is insulating unless it's under pressure. And then the molecules align and it becomes a conductor. That's really pretty neat. So, your track doesn't oxidize, neither do your wheels. Right? Now, Jimmy put it on a section out here and he hasn't cleaned it yet. So. I may have lost power. I didn't overheat the thing, did I? Let's find out why. Well, you saw it work a little bit. Okay. No, power's still on. All right, let's see. No.